everyone, welcome to day 2 of distance learning. For today, we're going to be completing the 4.2.1 part 2 packet that you received in class 2 weeks ago, the last time that I saw you, so please bring that out. Of course, all of this should be filled in because we completed 4-60 in class, and then you had letters C, D, and some review preview problems for homework. What we're going to do today is complete 4-61, 4-62, and 4-72. So we're going to do these two problems together. And then your assignment is going to be to complete 4-72 on your own, take a picture of it, and upload it to Google Classroom before midnight. Remember, I'm not accepting an email unless we had spoken about it, but you are to upload a picture of this by midnight tonight. If you are my Block 4 Essentials class, your packet looks a little bit different, the formatting, but it is exactly the same. So what you should be doing throughout this video is following along and writing on your packet everything that I'm saying and doing. And of course, please pause or rewind if you miss any important information. I would highly suggest having like colored pens, pencils, pens, just because we're going to be shading for one problem today, and you're going to have to do some shading for the one problem in the review preview that you need to do on your own. So I already started this problem because I had been doing this video already and I kind of messed up and I wanted to stop and start again. I didn't do much, but let's just read 4-61. So next, Bert and Ernie were working on solving the inequality for absolute value x plus 1 minus 2 is greater than 6 from problem 4-59. This time, Ernie had an idea. Why don't we find the solutions to this by graphing a system of equations like we did in problem 4-58? So instead of solving this algebraically, we're going to solve it using the graph. And you guys had a very similar problem on your classwork packet from yesterday on your solving inequalities review. It was number 3 that you were supposed to solve with no algebra and just the graph. So in letter A, it says, what system of inequalities should they graph? And if you remember from before we took the quiz when we were just solving systems of equations and you had like an equation on each side with an equal sign, you kind of just separate and graph them both separately. So we're going to take the absolute value and we're going to take the 6 and we're going to graph both of them and we're going to use their graph to solve the original inequality with the greater than sign. So if you don't remember how to graph this, that's okay. You can use a graphing calculator or Desmos, and Desmos is even better because you can just kind of scroll up and down really easily, not have to worry about changing your window, and you can hover all like the whole number points and just graph whatever it is that you see. So I already finished the graph. Absolute value graphs are always V-shaped. So that's already on my paper. And then I also graphed y equals 6, which is a horizontal line on 6. So now it says, graph the system and explain how you can use it to find the solutions to 4 times the absolute value of x plus 1 minus 2 is greater than 6. So we're going to hone in on this graph right here, and I see that my inequality symbol is greater than. So in just plain terms, we're looking for where the absolute value graph is above 6. So you're looking for the x values where the absolute value is above 6. So let's look at our graph. And we're going to look at all the x values. And we want to see where the absolute value graph is above the horizontal line, or above 6. So if you just look here, I see that right here, my absolute value graph is above the horizontal line. I see that down here, between these x values, it is below the horizontal line. And then I see out here that for these x values out here, again, my absolute value is above the horizontal line, and we want to be looking for where it's above because it's greater than sign. A synonym for greater than is just above. So if you look, my intersections play a key role. If you were to solve this algebraically, you would get your boundary points of -3 and 1 because that's where the two of them intersect. So do they... are you going to look in between or outside of them, like the typical format of the answers that we normally get for these with 2 boundary points? So if you can see here, between them, the absolute value graph is below the horizontal line, but we don't want where the absolute value graph is below. We want where it's above for the greater than sign. So it's going to be outside of them that the V shape is above the horizontal line. So your solutions are just outside, so below -3 and above 1. And we write our solutions as below -3 or above 1, and your directions did not say that you had to use a number line, so we are done. Remember, if the original does not have the equal to sign, neither do your solutions. So please let me know if you have any questions on this. You can comment on the video or comment on Google Classroom. I'm going to flip over to the next page, and we're going to start a system of inequalities now. So again, we're going to have to use our graph. You can use Desmos, but let's start off with some beginning problems. It says in 4-62 in problem 4-58, you looked at solutions to an inequality with one variable. Now consider system of inequalities with two variables. So our solutions are going to look a little bit different, but the process is not necessarily that different. So our system right now is y is greater than or equal to 2x squared plus 5x minus 3, as well as y is less than x squared plus 4x plus 3. So in letter A, it says, which points make both inequalities true? For example, does the point -3, 0 make both inequalities true? What about -1, 1 or 1, 5? So the way that we find out if points work and make a system of inequalities true is we just plug them in for x and y. So for the first point, if you have -3, 0, we're going to plug in -3 for x and 0 for y, and it has to work for both of them, not just one, because remember, a system of equations, a system of inequalities, the coordinate point that you pick needs to work for both. That's the whole point of these. So I'm going to go ahead and try -3, 0 right here. So I'm going to plug it into the first one. And then I'm just going to do this in my head, but if you don't want to, that's fine. You can also plug this into a calculator. So -3 squared is 9. 9 times 2 is 18. And then here I'm doing 18 minus 15, which is 3, and then 3 minus 3 is 0. If you plug this entirely into your calculator with the parentheses, which is important because then it'll do the PEMDAS for you, you should get 0. So is 0 greater than or equal to 0? Yes, that is true. Now, we don't know for sure that it works because it has to also work for the other one. So let's plug into here. I'm just going to do it below. So 0 is less than -3 squared plus 4 times -3 plus 3. I'm going to simplify this in my head again. So that's 9 minus 12 is -3, and -3 plus 3 is 0. So is 0 less than 0? Well, not quite. It's equal to, but it's definitely not less than. So -3, 0 is definitely not a solution to the system of inequalities because it doesn't work for both. Right now, we're going to try the other point, which is -1, 1. Same process. You should be writing this down in your packet and following along with me. I apologize if it gets blurry at some points, but 1 is greater than or equal to 2 times -1. Again, you can plug that into your calculator or just do it in your head. So that's 2 times 1 is 2. 2 minus 5 is -3, and -3 minus 3 is -6. So is 1 bigger than or equal to -6? That is definitely true. Plug into the other one. -1 squared is 1. 1 minus 4 is -3. -3 plus 3 is 0. So is 1 less than 0 now? This is not a solution either because it only works for the first one and not both. So neither of these are solutions to the system at all. Let's try the last one, which is 1, 5. Again, we're just plugging in for x and y, and we're seeing if it's true. So 1 squared is 1, 2 times 1 is 2, 2 plus 5 is 7, 7 minus 3 is 4. Is 5 bigger than or equal to 4? That's a yes. Let's check for the second one now. One squared is 1, 1 plus 4 is 5, 5 plus 3 is 8. Is 5 less than 8? Correct. So this is the only coordinate that they gave that is actually a solution to the system of inequalities. Now, is that the only solution? No, there's definitely other points that will work for this. And we're actually going to find the solutions and represent them later on. So now in letter B it says, what is the difference between a solution to the system of inequalities above and a solution to the inequality found in problem 4-58. Well, they kind of reminded us before, but in problem 4-58, the only variable was x. Here we have a variable of x and y. So the only difference is we're going to be finding the full coordinates that are solutions, not just the x value. So for a system of inequalities, the y values are also part of the solutions. Not just the x values in parentheses. This really relates to your system of equations because when you solve a system of equations using substitution or elimination, you know that you have to plug back in to find either the x or the y value. So you need a coordinate as your solutions as opposed to just the x value. In letter C, it says, how are the graphs of the equations y equals 2x squared plus 5x minus 3 and y equals x squared plus 4x plus 3 related to the graph of the system of inequalities? And again, this relates back to our notes and what we've been doing with the inequalities, but you solve an inequality as if there was an equal sign. So it's pretty much going to be the same graph. We're going to graph as if there were equal signs. So same graph. Graph them as if they had equal signs. And that brings us to the last part, which is letter D, where we actually solve this and represent all the solutions. So in letter D, it says with your team, and obviously you're just doing it by yourself, but find a way to represent all of the solutions to the system of inequalities on the graph below. Should the graphs be connected with solid or dashed curves? So although we haven't done an example like this, it really does relate to your number line where you use an open circle or a closed circle and you kind of draw your arrow to represent where the solutions are. But in this case, we're going to shade, which is why I suggested that you have some colored pens, markers, pencils, highlighters, whatever you can use to shade. So we're going to graph the two parabolas, and I know they're going to be parabolas because they're both squared, and I'm just going to use Desmos because I can just kind of highlight the points and easily graph both of these. So the red parabola, which is the skinnier one, I know is the 2x squared because the 2 makes it skinny. So I'm going to graph the red one first, and it looks like it has an x-intercept on -3, 0. It has another x-intercept on 0.50, which is like right here. Another good point is this y-intercept, which is 0, -3. Its vertex is on -1.25. Okay, so -1.25, -6.125. It's like right here-ish. Kind of just eyeball it. And when you do graph these three inequalities, I want you to be as accurate as possible. I understand it's not going to be perfect, but if you could just try your best, that'd be great. So what other points do I see that I can kind of scroll up at? There's this point right here. -2.5, -3. Which is kind of symmetric to the y-intercept. And then if I scroll up, oh, I see 215. So mine only goes up to 10. I'm going to count by something, which means I suppose I should have counted by something all along. But you know what? That's fine. They intersect somewhere up here on that side. And then on the left side, they do intersect at that other x-intercept, which is really good news. Okay, so I'm going to kind of just figure out how I'm going to connect my dots right now. So if you look back at the inequality for this narrower parabola, it's greater than or equal to. So normally on the number line, you would put a closed circle, and that's kind of like the same idea here. So are you going to do a solid or dash curved or solid or dash line? We're going to do solid because it's greater than or equal to, and it's including the parabola. So solid is kind of equivalent to a closed circle. Okay, now before I do any shading, I'm just going to graph the other parabola because it's easier to see the shading when I have the full graph of both. Right now, I'm going to graph the blue one, which is the one that's not skinny or wide. So it also has -3, 0. It has a vertex at -2, -1. It also has an x-intercept at -1, 0. I know it also touches that point that we did up here because that's where they intersected on the right side. It has a y-intercept at 0, 3. And that means it's kind of symmetrical on the other side from the vertex. So somewhere there. And then, is that really the best that I can do? Look, -5, 8 looks like it's a point as well. And it should be symmetric. It's 3 away from the vertex. Okay, so I'm just gonna figure out how I'm gonna connect those dots because I kind of have pretty much a full graph, it looks like, if I were to connect. So I go back, and it's just a less than symbol for that parabola, and that means it's not included. So kind of in the same way that you would use an open circle, we're gonna use dashed to connect the dots. I'm gonna do this in pen to show that it's a different graph. Dashed. And remember, your graphs are never going to be perfect when you do them by hand, but as long as you graph some accurate points and it kind of looks okay, it's a good representation. Okay, so now we're going to represent our solutions. So it's pretty straightforward when it comes to this part. Let me just summarize what we did. So y is greater than or equal to 2x squared plus 5x minus 3. We did a solid curve, and it's solid because it's including, right? It has that line just like it's a closed circle for the including greater than or equal to, less than or equal to. And then for the other one, the other parabola, we did dashed because it's not including, it's only less than. Okay, so let's figure out what we're going to shade. So right here for this parabola, the skinnier one, the first one that we graphed, greater than or equal to, you're always going to shade above because greater than, just like we've always been saying, a synonym is above. So we're going to shade above for greater than. And even if it was just greater than or equal to, you always shade above. Now that means for less than, we're going to shade below. Because another way of saying less than is just below. So I'm gonna, if you want to shade with 2 different colors, that's perfectly fine with me, but I'm just gonna find the overlap right off the bat. So when you do your shading, your solutions are just gonna be where they overlap, because where they overlap is gonna be the coordinates that satisfy both of the inequalities and not just one, it has to satisfy both. So if I were to shade, hold on, let me get my, if you were to shade above the skinnier parabola, which is the one that dips more below, and then below the other parabola, which is the one right here that's dashed, you can see that the shared shaded region is just going to be this space in between them. So those are going to be my solutions. And I'm going to take this green pen, and I'm going to shade all this in between. And remember, it goes all the way up to where they intersect up here, and then they also intersect here. So you can see that it's going to be between their intersections. I believe it was -3 and 2, but you have to show the full shaded region, so it has to be all the coordinate points x, y that satisfy both of the inequalities. So just to reiterate, we shaded above the skinnier parabola and below the dashed parabola, and the shared region is just this space in between them. That's how you represent the solutions to a system of inequalities. You always shade, so do your dashed, do your solid, and then shade above and below, and then you can kind of indicate where the shared shaded region is. If you did your shading separately, 2 colors for this, I just want you to point an arrow to this, indicating that those are your solutions. That's your solution region. Your last part is to just pick a point from your solution area and test to see if it satisfies the system. So again, if your graphs and your shading were not entirely accurate, you just have to be careful because you might pick something that wasn't supposed to be in the shaded area. I'm just gonna pick something that looks like it's kind of in the middle. So I'm gonna kind of pick out, let's see, maybe like -2, -3. It's kind of really in there, so I feel like that'll work. So let's plug in -2, -3, and exactly like what we did in letter A, it should work for both. So plug it into the inequalities. I'm plugging in -2 for x, and it should be true, hopefully. Again, I'm going to do this in my head. -2 squared is 4, 2 times 4 is 8, then I'm subtracting 10, which is -2, and then subtracting 3, which is -5. So is -3 bigger than or equal to -5? It sure is, and we should also be plugging into the other one. Is less than. -2 squared is 4, and then we're subtracting 8, which is -4. And then we're adding 3, which is -1. So is -3 less than -1? Yes, it is. So -2, -3 is definitely a solution, but we know that all the green area, all the coordinates that cover the green area are solutions. Your assignment right now is to just do 4-72 in the review preview on your own. If you need any help, please post questions on Google Classroom, or you can even comment on the video down below. But you just have 4 of these to graph, and hint, hint, they're not going to be parabolas. I hope you know the reason why. Make sure that when you graph these, y should be solved for, and you can either graph based off of the clues that you know with the function family that these belong to, or you can go and type them in Desmos. But remember, they can't be graphed in Desmos or by hand unless they are in y equals form. Again, shade above for greater than or equal to, shade below for less than or equal to, and then you should be connecting with dashes if it's less than or greater than, and you should be connecting with solid if it's greater than or equal to, less than or equal to. And then it kind of has this extra question right here that when you find their shared shaded region, when you shade above, below, and all that, it does make a shape, your final shaded region, and you're supposed to tell me what type of polygon it is or what type of shape do they make in their shared area. Please take a picture of this and submit to the Google Classroom posting by midnight tonight. And you should also be working on your quiz corrections. Those are due by Friday, and I will take questions on those as well. Enjoy the rest of your day, and I will see you, quote unquote, tomorrow. Bye.